So we're on 1A.3 scatter plots and regression models. We're going to start with part one. Part one is where we're talking about scatter plots and determining the line of best fit. Well, if a line would be the best model for it. Okay. So that's where we're starting at. All right. Do y'all remember seeing scatter plots in middle school? All look familiar. No one's like, I've never seen one of these. Okay. So then you should have talked about different types of scatter plots. Is it positive? Is it negative? Is there no correlation? Is it constant? And so when we're talking about linear, we're asking ourselves, is a linear the best model for the situation that we have? And from there, we determine whether it's positive, negative, constant. Okay. If it's no linear correlation, then it's just no linear correlation, right? And we can say, okay, well, this would be a better model. Does that make sense? All right. So looking at number one, is this a linear correlation? Yes, it is a linear correlation. And what kind of linear? A positive linear correlation. Good job. Okay. It's linear because I could essentially draw a line that would show a pattern, correct? Number two, is it a linear correlation? No, there's a curve in here. There we go. It is no to being linear correlation, but it is a exponential. Number three is a little tricky. Is number three a linear correlation? It's a yes, no. Okay. The reason why it's a yes, no, it's a yes, based on the fact of where your knowledge of level is. Like you could say this is a constant linear correlation, right? That's the numbers are close enough where you can say that I could draw essentially a horizontal line approximating the change, right? Roughly there, correct? However, it is a no correlation. It's called a sinusoidal pattern, which you'll learn about in pre-cal. So it makes a sine wave. So we would actually say no linear, but if you had put constant, I would understand. Does that make sense? Because you know about sine waves. No, you don't. But you can see that there's a constant. All right. What about four? No. No linear correlation. Is it okay that I'm not writing the whole no linear correlation? We're okay with just no? Okay. Sorry, I was being a little lazy right there. All right. Number five. Five is? It is a yes. It's a linear correlation. And it's a positive. All right, what up? Six. Six is, it's a no linear correlation. Can anyone say what kind of model it could be? Quadratic. We could see that possible parabola being created. Do you see it? All right, seven. Seven actually is yes. It is a linear. It's not a perfect linear, but it is yes, a linear correlation. And that would be a positive correlation. And the trend is that as they create more boats in the ocean in Florida, right? More wildlife is experiencing death by watercraft. All right. What about eight? Eight is yes, but it has a little thing. Does anyone remember what these are called? Outliers. Good job. It's those random occurrences that sometimes can throw off your data, right? So it's a yes, but we do understand that there is a presence of outliers. So what I want y'all to do is, after we've gone through and labeled, at your table, I want y'all to read what the axes, what the X and Y axis represent. And based on what we said about linear correlation, does that make sense for the scenarios that are being measured on the graphs? Okay. So I'm gonna give y'all a moment, read the actual axes. So for example, in this one, this is our X-axis is the number of haircuts given. Our Y-axis is the total income per dollars. Does that make sense? Does that represent a linear growth? I cut more hair, I'm going to make more money. Yeah. Okay. So looking over really quick, have a little conversation, and we will resume from here. While you're looking over, if you don't already have a calculator, please make sure you get one out.